I'm going to go ahead and run through arc length and sector area. Now this lesson is going to be pretty much identical with geometry, so it'll serve for both courses. And what we're going to do is run through a couple of examples. But first of all, we're going to talk about arc length. Arc length is simply a length of part of the circumference. This length right here. And we don't know what that is, but we know the circumference is 2 pi r. As long as we have a radius, we can figure that out, or we can work backwards given an arc length. So we're going to take a percent of that circumference to find the arc length, and that percent can be part over, well, 360 degrees, the whole circle, or it could be measured in radians, which we're going to do in Precal. And because we're at home learning, I doubt we're going to do radians that much in geometry. We'll see what happens. And the central angle is going to be theta. So we have a simple formula for that. Now if we're doing area, we're going to be looking for the area of this sector. Well, the area of a sector is nothing more than pi r squared. And we're going to take a percent of that as well. So arc length is we're taking a percent of the circumference, and area we're taking a percent of the area of a circle. So let's look at a couple examples here. So, well, here's the formulas. Now the key for this is that in Precal, these are going to be in radians. All right, so if you're in degrees and you want to use this formula, you're going to convert it to radians, which of course from degrees is nothing more than pi times 180 to convert that, okay? So you're just going to take your radian, if you're going to take your degree, if you say you're getting 50 degrees, and put it over that. But we have an easier way of doing that. We're going to show you, or remind you of the geometry way of doing it. Area of the circle, again, this is in radians, all right? So we're going to have 1/2, remember, pi r squared, and then we're going to multiply it by the radians. So let's go ahead and take a look at an example here. So we're going to find the area, so that's going to be pi r squared, right? Area is pi r squared, we're going to take a percent of that. So the next thing we're going to do is we need to identify the radius and our central angle. Our central angle is given in radians, so we don't have to convert. So we're going to just simply do 1/2 times 2.5 squared times 5 pi over 7 in the calculator. And I already did that because this computer does not like it doesn't like my calculator. When I try and do 2 programs at once with my writing tablet, it freezes. I really should get a better computer someday. Alrighty, and so when I put it in the computer, I can get exact or approximate, and it's asking for approximate to the nearest tenth. So it's going to be about, what are we in, meters? Yeah. Area is going to be about 7.0 meters squared, all right, for that little slice of pie. Let's go to the next one. Here we're looking for length. Now remember, length is going to be part of my circumference times the percent. This is in radians, so we're going to have radius times this. But our geometry formula is nothing more than our circumference times the part of the circle over the whole 360 degrees of the circle. So we don't have to convert. You can if you want to. You could certainly do 75 times pi over 180 and turn that into a radian, 75 pi over 180, and plug that in right there, and then multiply it times the radius, which is 14. R is equal to 14. But why bother? It's just too much work. I'm going to do 28. There's my r times 2 pi. No, times pi. That's 2r. So 28 pi, okay, times 75 over 360. And that's exactly what I did right here. So I did it in the calculator again. I can't touch my calculator. And I got 35 pi over 6, or 18.3. So the length is about 18.3 centimeters. Alrighty. So that's it. You just plug and play on these. And I do have a geometry video that covers these as well with other examples, but I'm using primarily this formula. Okay, we don't do a whole lot of this in Precal until we get to circular motions, angular velocities, things like that. Okay, alrighty, I will catch you later.